All right, part 2 of final exam review. Again, this is not comprehensive, it is just some key problems. We're going to cover a polynomial function. Other things for a quadratic is you will have an applied maximum or minimization problem. So take a look at numbers 10 and 11 on the review. For a polynomial function, if we take a look at, say, number 13b, we have f of x is equal to 5 times x plus 3 to the 4th times x minus 4 times x minus 6 squared. You'll have to list out the zeros, the multiplicity of each zero, and whether it crosses or touches. Wow. Touch, cross, or touch. Alright, so looking at the first one, 5 doesn't give me a 0 because it doesn't have an x. So I have x is equal to negative 3, multiplicity of 4, which means that it touches. Next bucket, I have x is equal to 4, multiplicity of 1, which means that it crosses. X is equal to 6 from the last one, multiplicity of 2, which means it touches. Now, overall, the degree of this function is equal to 4 from the first one, 1 from the second one, 2 from the third one, gives me 7 overall. Now, remember, if I have an even polynomial, like even degree, it looks either like this, for positive, or like this for negative. If I have an odd polynomial, like this one, then if it's positive, it looks like this. If it's negative, it looks like this. So this is an odd polynomial and it's positive, so I expect the final result to look like this one. And going through, I'm just going to put my zeros on this axis. So I've got a 0 at negative 3, I've got a 0 at 4, and a 0 at 6. And then I'm going to follow my end shape. So at negative 3, I'm going to touch. At 4, which is the next one I come to, I'm going to cross. And at 6, I'm going to touch. And I should pretty naturally end up in that shape. If I don't, I've done something wrong. So expect some sort of analysis of a polynomial. Looking at the next piece, I want to analyze a rational function. So you will have to analyze a rational from start to finish. And I'm going to choose 14a. 14a is f of x is equal to 3x squared minus 6x minus 9 over x squared minus 4. So the first part of this is to factor the whole thing. So if I factor that, I have 3x and x on the top. I know that they have to be 3 and 3 to give me 9, or 9 and 1, but that's kind of unusual. And looking at the sign arrangement, I need negative 6 in the middle, so I'm going to do negative positive. Looking at the bottom, x plus 2, x minus 2. So things I need, domain. Domain comes from the bottom, so x cannot be positive or negative 2. So negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. Alright, now we see if we can simplify the function. So can you cancel something top and bottom? This case we can't. So if we're looking at, say, vertical asymptotes, if you can't cancel anything, that means your problems in the domain are your vertical asymptotes. So x is equal to 2, x is equal to negative 2. For your horizontal asymptote, you have your three rules of a function, of your rational functions. So if the top is greater than the bottom by degree, then you have none. You could have an oblique if the top's greater than the bottom by 1. If the bottom is greater than the top, then you have y is equal to 0. And if they're equal, then you have y is equal to a ratio of the leading coefficients. And that's the case we're in here. So our leading coefficients are 3 and 1, so y is equal to 3 over 1, or 3. Last part is intercepts. X-intercepts are when y is equal to 0. So we get 0 is equal to the top. Because if we set 0 equal to the whole thing, the first thing we do is multiply by the denominator. It cancels out our denominator. So here I get x is equal to 3. This first one I could factor a 3 out in the front if I wanted to. So I end up with x is equal to -1. For the y-intercept, if there is one, I plug in zeros for x, so I get y is equal to 9/4. Now, ordered pair-wise, this would be the points 3, 0, and, I'm way at the bottom. Let me move this up. So it would be the points 3, 0, and -1, 0, and the other one would be the point 0 and 9/4. All right. Okay, so now we're at the point where we can graph our function. So I'm going to make a graph. And 1, 2, 3, 4, 5. Wow, those are nice and even there. Everything that I have found so far, I'm going to put on the graph at this point. So first thing is my asymptotes. I have one at -2 and one at x is equal to +2. I have a vertical asymptote at y is equal to 3, or a horizontal, sorry, at y is equal to 3. Now remember, horizontal asymptotes are used for shaping, but you can cross one. Vertical asymptotes are a no man's land. They are problems in the domain, you can't cross it. So looking at our next part, I am plotting my intercepts. So I have one at 3, 0. I have one at -1, 0. I have one at 0, 9/4. All right, rest of the stuff I need to figure out based on a sign chart. So, so I'm going to make myself a little axis down here, and I'm putting some important values on this axis. So these are my intercept points and undefined places. Intercept points for x, undefined places. So I have at -2 and at 2, my function's undefined. Those are asymptote lines. And at -1 and 3, I have my intercept points of x. So these are the only places where the function can change from negative to positive or back. So I need to find some points in order to test whether the function is positive or negative in each region. Now remember that it's either, the function itself is either going to look like this or like this. It's going to go like this, or it's going to go like this. These will erase, don't mark these down. It's going to go like this, or this, one or the other. Remember that rational functions are all defined like the parent function 1 over x, so they're shaped that way. So if I'm looking in the first region, so this region over here, the first thing that I'm noticing is there is not an x-intercept. Since there's not an x-intercept, there is no way for me to be in that lower piece because it would have to cross the x-axis at some point. So I'm pretty confident that this one is going to be up here somewhere. If you want to get an actual guide point for there, please feel free to do that, but this is the shape that it's going to be. Now for my next region between -2 and -1, it is likely going to be down from the bottom, but just to check, let's say we do -2 or -1.5 for a value to check. If I'm looking at this piece and I were to plug in -1.5, then my first bucket, -1.5 times 3, is a number bigger than 3. So that first piece would be negative. Negative minus a number is always negative. Negative plus 2, or -1.5 plus 2 gives me positive. But this piece is also negative. So overall, I have a negative value in this region, which means that it comes in from the bottom and touches that intercept point. Now some intercepts will turn around and go back down. This one will not, because I've got a 0 or a y-intercept up here. So it's forced this way. Now the question is, does it go up through or does it come back down? It goes up through, and the reason I know that is because there is no additional x-intercept in that next piece. So this function has to go up through here. Whoa. The pen has gone a little astray. Alright, so let's try that again. It has to go up. Bad spot in the board. Let me scroll this down and we'll try that again. Alright, so it has to go up and out that way because there is no x-intercept point in the second part of that. So it's going to go out in this direction. Now for the last part, remember that the intercepts are, you have to actually touch or cross at an intercept, so I've got an intercept point there. And it likes the asymptote line for shaping. So my options for this one are that it could either come in from the top, touch this point, and then go back this way, or it's going to go from the bottom, go through at that point, and do that. Much more likely that it comes from the bottom, but we can check it. So if I choose a point between 2 and 3, let's say that I choose 2.5, then looking at the top, 2.5 is positive, plus a positive gives me a positive. 2.5 minus 3 is negative. 2.5 plus 2 is positive, and minus 2 is also positive. So I've got negative overall, which means that I come in like this. Now I'm going to cross and go toward my asymptote line, and here is a picture of what we end up with for our rational function. Alright, last one for this video is finding the possible rational zeros and factoring an entire higher order quadratic, or higher order function. Let's say that we do number 15b, and it says g of x is equal to x cubed minus 6x plus 4. So we need to list the possible rational zeros for this. Now this one doesn't have a whole lot. Our coefficient for our leading term is 1, so I have only whole numbers. And they're all factors of 4. So I could have plus and minus 1, plus and minus 2, or plus and minus 4. Now it wants us to go through and find them. It says x is equal to 2 is a 0. So I'm going to put in 2, do some synthetic division. Only sticker for this one is I'm missing a square term, so I need to put a 0 for that. And completing the synthetic division, 1 times 2 is 2, 2, 4, negative 2, negative 4, and 0. So now what I'm left with is f of x, g of x, g of x is equal to x minus 2, from that x equals 2 being a factor, times x squared plus 2x minus 2. And then I have to take a look at this one. Now, it doesn't factor, So I have choices for -2 would be just 2 and 1, and none of those add up to +2. So I have to use the quadratic. X is equal to -b plus and minus the square root of b squared minus 4 times a times c all over 2a. So -2 plus and minus. Inside my square root, I get 4 plus 8 gives me 12 over 2. So I can simplify 12 into 2 square root of 3. So I'm going to simplify the 2 all the way around. So -1 plus and minus the square root of 3 for my zeros. Putting the function all the way together, I have f of x, g of x. Next time I'm going to write these all with f of x's. G of x is equal to x minus 2 times x minus -1 plus the square root of 3 and x minus -1 minus the square root of 3. You can do plus and minus and that's fine. Alright, there will be one last section and it is coming up here shortly.